Alright, let's read the directions to this problem. What values for x and y will satisfy the system of equations? Given x minus 1 equals y plus 13 and negative 3x minus y equals negative 18. A system of equations just means that you have two or more equations. So here we have two equations. We can call that a system of equations. Values for x and y that satisfy the system just means what number could I plug in for x and what other number could I plug in for y, that if I did that, the left side of this equation, something minus 1, equals the right side, something plus 13. For it to satisfy the system of equations, those numbers would also have to work for the second equation. So the same two numbers, plug it in for x, plug it in for y, and you would multiply negative 3 times something minus something else equals negative 18. Now you're not guaranteed that there's a solution, but remember that if you graph a system of equations, it makes two lines. So you could have two parallel lines, which means that there's no solution. They don't cross each other ever. But many times, two lines will cross at a point, and that point has coordinates x and y. And it's the value for x and y at that point where the lines, if we graph these equations, cross. Those values are the numbers that if you plug them in to one equation and plug them into the other equation, that the left side of the equation will equal the right side of the equation for each equation. So there are three ways to find those values or solve this system of equations. One is by graphing, but we don't have graph paper. And so we're not going to try to graph these numbers without some grids and a ruler. Another method is called combination. And combination works pretty well if when you line up the equal signs in the two equations, if every type of expression, like expression that contains x, would line up with each other, and the expressions with just numbers would line up with each other, which is true here for the most part, but if we look real closely and we line up the equal signs exactly, so negative 3x lines up under the x from the other equation, but then we've got this minus y, and that lines up with a number, and so there's no y in the first equation, so it doesn't really line up how we want it to use the combination method to solve. And if we continue, negative 18 on the right side of the equal sign, that lines up with a 13 over there, but there's no y on the right side. Now we could do a little bit of work and add y to each side and turn this equation into one that we could use combination, but instead of doing that, we're going to use substitution. And in this problem, it's really up to you. If you think that combination is easier, you could go ahead and give that a try. But we're going to use substitution to get some practice on that. So to use substitution, you need a variable, either x or y, all by itself on one side of the equal sign in one of these equations. Now, it's up to you which x or which y or which equation you want to do this, but if you look at the top equation, I can see that there's only one thing happening to this x. It's being subtracted by 1. I could quite easily undo that by using the inverse operation and add 1 to each side and get x all by itself. So that's what I'm going to do. I'm going to change this equation to be x. So I'll just rewrite it first. But I'm going to add 1 to each side of the equation, and that gives me x. Negative 1 plus 1 makes 0, so there's nothing left there, equals y, and 13 plus 1 makes 14, positive 14. Now that I have x all by itself, I know that x equals this stuff on the right side of the equal sign. I'm going to take that stuff and I'm going to substitute it or replace the value for x in the other equation with this stuff that I know is what x is worth. So, for example, I'm going to take negative 3. Now where the x is, that's where that stuff goes, because that's what x is. So I substitute it, y plus 14, into those parentheses. Okay, now I can finish writing this equation, minus y equals negative 18. Okay, so now that I've done the substitution step, I've taken this stuff and I've substituted it in where the x was. If you notice, my equation just has one type of variable now, it's just got y's. And anytime that you have a situation where you just have one type of variable in an equation, you can then simplify and solve that equation and find out what that variable is worth. So to do that, I've got y's in different places and numbers in different places. First I'm going to simplify. And to do that, I'm going to do the multiplication, and I'm going to distribute that negative 3. So negative 3 times this positive y makes negative 3y, and negative 3 times positive 14 negative times a positive makes a negative, and 3 times 14 makes 42. Minus y equals negative 18. Okay, now I still have y's in different places, so I'm going to combine those expressions. Remember the sign goes with the term to the right, so I've got a negative 3y and a negative 1y. If you don't see number, it's a 1. I'm going to combine those. I have negative 4y minus 42 equals negative 18. Okay, now I just have one expression with a y, one expression with numbers. I can solve for y. And remember, to solve, use PEMDAS backwards when you solve. Okay, so I'm going to ask the question, what's happening to y? Y is being multiplied by negative 4 and subtracted by 42. So starting at the bottom of PEMDAS, is y being subtracted? Yes, it is, by 42. So I'm going to undo that using the inverse operation and add 42 to each side. And that leaves me with 0. So all I have left on the left side is negative 4y equals, and that is 34. I'm sorry, 24. Okay. Now I ask, so subtraction, we've undone that using addition. Is y being added by anything now? Nope. So we can skip that. Is y being divided by anything? Nope. So we can skip that. Is y being multiplied by anything? Yes, by negative 4. So I'm going to undo multiplication using the inverse, which is division, both sides, by negative 4. And a negative divided by a negative makes a positive, and a 4 divided by 4 makes 1. And 1y, we just write y, equals, and 24 divided by negative 4 is negative 6. Okay, we have found the value for y, but we've been asked to find the values for x and y. So now, take that answer for y, and we're going to do the same thing that we did in this step, is that we're going to substitute. We're going to substitute the negative 6 into the equation where y was. Now, this equation is a great one to use because we've already solved for x. So, if I bring this equation down here, I say x equals y plus 14, you can see that if I just plug that negative 6 in for y, it makes it pretty easy to find out what x is. I just have to combine those two numbers. And negative 6 plus 14 makes 8. So I've got my two values for x and y. 8 for x, negative 6 for y. And those are where, if we were to graph these two equations and made two straight lines on a graph, that would be the coordinates of the point where those two lines cross. It would be 8 for x, negative 6 for y. All right, thank you for watching. Please make sure to check out the other videos at askmath.com.